This concave mirror has its center of curvature at C, and the pole of the concave mirror is at P. This line joining the center of curvature and the pole is the principal axis. Now we have to find out a relation between the radius of curvature of this concave mirror with its focal length. Do you think there exists a relation between the radius of curvature and the focal length for the concave mirror? Let us find out through ray diagrams. Now firstly, we consider a ray that is traveling through the center of curvature along the principal axis. This ray is incident on the concave mirror at its pole. Now since it traveled through the center of curvature, after reflection it will retrace its path, so the ray is reflected back in the same direction. Now we consider another ray. This ray will be parallel to the principal axis. After being incident on the concave mirror, this ray will be reflected. Now since this ray is parallel to the principal axis, it will be reflected through the focus of the concave mirror. So the distance from the focus to the pole is f. This is the focal length, and the distance from C to the pole is r. This is the radius of curvature. We have to find out a relation between f and r. Now since the ray AB is reflected and the reflected ray passes through the focus as BD, so if we draw a normal at the point B, we will find that the angle of incidence is equal to the angle of reflection. Now we have to prove if there exists a relation between f and r. Now as we know, angle ABC, that is this angle, is equal to angle CBF, which is this angle. Why? Because according to the law of reflection, angle I is equal to angle R. That is, the incident angle is equal to reflected angle. Now angle BCF is equal to angle ABC because they are a pair of alternate angles, angle BCF and angle ABC. So thus we can say in triangle CBF, that is CBF, in triangle CBF, angle BCF, that is this angle, is equal to angle CBF, which is this angle. Why? Because angle I is equal to angle R. Now since this angle is equal to this angle, we can say that CF, side CF, is equal to BF, that is this side. Thus, if the point B, that is the point at which ray AB is incident, is very close to the pole, that is point P, then what can we say? We can say that BF is equal to PF. And we have also seen that CF is equal to BF. So what can we say? We can say that CF is equal to PF. That is, CF is equal to PF. Here PF is F, that is the focal length. Now let us find out how we can relate R with F. As you can see from the image, PC, that is given by R, is equal to CF plus PF. And what have we learned? That CF is equal to PF. So what can we say? We can say that PC is equal to PF plus PF. Here we know that PF is nothing but the focal length, that is F. And PC is nothing but R, that is the radius of curvature. So we can write R is equal to F plus F, which gives us R is equal to 2F. And this gives us F is equal to R by 2. Or in other words, for a concave mirror, the focal length is half of the radius of curvature. Now let us consider what happens in the case of a convex mirror. In the case of a convex mirror, we have taken a ray that seems to be passing through the center of curvature of the convex mirror. Now this ray, after reflection, will retrace its own path because it appeared to be passing through the center of curvature. So after reflection, the ray comes back along its own path. Now we consider another ray. This ray is parallel to the principal axis. This ray, after getting reflected, will seem to come from a point that is behind the mirror. So once this ray is reflected, it will seem to come from a point that is behind the mirror. This point is the focus. So after reflection, it seems to come from a point that lies behind the mirror. So this is the focus of the convex mirror, and C is the center of curvature for the convex mirror. Now we have to find out a relation between the radius of curvature and the focal length of the convex mirror. As you can see, the length PF is given by F, which is the focal length, and the length PC is given by R, which is the radius of curvature. We have to find out a relation between F and R. Notice that the angle of incidence for this ray is I, and the angle of reflection is R. According to the laws of reflection, these two angles are equal. Now, as we know that angle QP dashed N is equal to angle NP dashed B, that is, this angle is equal to this angle by the laws of reflection. Also, angle QP dashed N, that is this angle, is equal to angle FP dashed C, that is this angle. Why? Because they are vertically opposite angles. Also, angle NP dashed B, that is this angle, is equal to angle P dashed CF, that is this angle. This angle is equal to this angle. Why? Because they are corresponding angles, and corresponding angles are always equal. So now we consider a triangle, that is triangle FP dashed C. FP dashed C. In this triangle, we have angle CP dashed F, that is this angle, is equal to angle P dashed CF, that is this triangle, as both of them are equal to angle R or angle I. Thus, we can say that since this angle is equal to this angle, side P dashed F or FP dashed is equal to side FC. That is, this side is equal to this side. Now, if we consider that the point P dashed lies very close to the pole P, then FP dash, that is this length, is equal to this length, that is FP. If P dash is very close to P, we can consider FP dash is equal to FP. So what does this mean? This means that since FP dash was equal to FC and FP dash is equal to FP, thus FP is equal to FC. That means this length is equal to this length. So what does this signify? This signifies that we can write this whole length, that is PC, as PF plus FC, that is PF plus FC. And what did we just prove? We proved that PF was equal to FC. So we can replace FC with PF. So now we are writing PC is equal to PF plus PF. Now, as you can see from the board, PF is nothing but the focal length and PC is nothing but the radius of curvature. So what do we obtain? We obtain R is equal to F, that is PF, plus F, that is FC, since those two sides are equal. So we can write R is equal to twice of F. In other words, we can say that the focal length of the convex mirror, that is F, is equal to R by 2, that is half the radius of curvature. So summarizing, what did we learn? We learned that both in case of concave and convex mirror, the focal length and the radius of curvature are related. How are they related? The focal length for a convex mirror as well as a concave mirror is half the radius of curvature.